Hello everyone. I hope you're having a very great day. In today's video, we are going to be looking at Newton's laws, mostly specifically on angles or forces acting at an angle. Yes, we're continuing with that sub topic under Newton's laws calculations. Okay, so those who haven't subscribed, please click the red subscribe button. Please subscribe, guys. Yes, thank you so much. Please don't forget to subscribe again. Let's get into today's topic. Okay, so yes, so in this case, guys, we are given two boxes, okay, x and y. Didn't show this is x. Okay, so given box x and y resting on a rough horizontal surface, meaning that they are resting, they are non-moving objects at this particular point, are connected by a like inaccessible string. Okay, this is the inaccessible string connected both to both of these objects. The boxes have masses 5 kg and 2 kg, 5 kg, 2 kg respectively. A constant force of F, okay? We have a constant force of F here, acting at an angle of 30 degrees to a horizontal, okay, is applied to the 5 kg block, okay, as shown below. The two boxes now move to the right at a constant speed of 2 meters per second. Okay, so just before I explain the concept of this constant speed, so guys, okay, let me just explain it. So constant speed, okay, if ever you see in scenarios like this or any kind of a scenario in physics, if ever it's a constant speed, you should know that the acceleration is equal to 0. You should know, okay? You should know that the acceleration is equal to 0. Okay, maybe you're asking yourself, hey sir, but it's 2 meters per second. No, this is 2 meters per second for the velocity, okay? Acceleration is equal to change in velocity over change in time. If ever the velocity then is constant from this particular point to this point, if ever we have 50 meters per second and 50 meters per second, this basically means that we're going to minus 50 minus 50, and that gives us 0. 0 over divide with specific time, maybe let's say travels 15 seconds over 15, that gives us 0, okay? Acceleration is 0 then. I think you get me. So the particular point, the fundamental point that I want to emphasize to you is that the constant speed of 2 meters, okay, per second is that meters per second, okay? Constant speed, okay? I repeat, constant speed. The acceleration is equal to 0 in that case. I think I clarify that, okay? Yes. Okay, so the surface, it's a rough surface, okay? Yes, meaning that there's a presence of a frictional force acting on that particular, those two objects, okay? Yes. So that's how it goes. Okay. Okay, so that's how it goes. Okay, so the surface is rough. Just look, the surface is rough. So if ever the surface is rough, our question 2.3, if ever I jump, if you don't mind, to question 2.3 says calculate the magnitude of force F, okay? Yes, this particular force whereby the box, okay, the box X experiences a frictional force which is equal to 5N, and box Y experiences a frictional force which is equal to 3 newtons. Okay, yes, so let's get into our answers without wasting no time. Okay, mind you guys, I said to you the other way which is very effective for practicing, getting yourself familiar with these kind of questions in your Newton's laws calculations, you have to maybe pause the video. Okay, you can pause the video, then try to answer on your own and see if ever you got the right answers, okay, from me. Okay, yes, but you can watch, no problem, you can use, I was just advising you. Okay, so 2.1 says state Newton's first law of motion in words. Okay, let's state Newton's first law of motion in words. So you know that Newton's, okay, let me just write it. So Newton's first law of motion states that an object will always, let's emphasize that, will always remain at rest or on its uniform motion. Okay, on its uniform motion, meaning that an object will always remain at rest or on its uniform motion unless a resultant force or a net force is acted upon an object. A resultant unbalanced force is acted upon this particular object, or this particular upon it. Okay, yes. So Newton's first law of motion states that an object will always remain at rest or on its uniform motion unless a resultant unbalanced force is acted upon it. Okay, meaning that an object will always remain at rest, okay, at rest, unless you apply a certain force or unbalanced force on it, then it will move, or it will always on its constant motion. Okay, yes, unless the unbalanced net force is acted upon it. Okay, yes, so that's how it goes. So we can put in that way and so on. So okay, so let's answer our question 2.2. So question 2.2 says draw a labeled free body diagram for box X. Okay, so let's draw the free body box X, but I'm going to draw for them both. So this is for box X. So for box X we have this. Okay, you can see it's on the surface, there's normal force acting on it, and there is a gravitational force acting on it. And please guys, your vectors or your arrows must start from the point. Okay, they must not be like this. No, you can't. Okay, you can't do like this and so on. Okay, it must start from the point. Okay, you lose marks instead. Okay, yes. So so this is the force applied. Okay, yes. So this is your 30. This becomes a 30 degrees, and there's a friction there. Okay, yes, in that box X, the friction, magnitude of the friction is smaller than this one. Okay, than this one. Okay, So this is the your friction. Okay, yes. So this is your F force applied. Okay, I think okay. Also we have the tension. Okay, that is also acting here. I almost forgot. The tension that is acting on this 5 kg block. Okay, yes. So acting in the same direction as the frictional force. So the tension force acting here, which is caused by this inextensible string. Okay, so you have your tension force. This is your FT, your tension force. Okay, yes, the tension force is there. Okay, it's marked. This is your tension force caused by this string. Okay, this is whereby a 2 kg block is pulling back this 5 kg block while it's moving forward. The tension force is there. Okay, and this is your normal forces on the ground. Normal force. Okay, yes, acting perpendicular to the ground, or from the ground. FG, so sorry, you see these mistakes I always do, guys. It's called to weight. And you have the gravitational force, and this is your the applied force. Your force is there. This is your 30 degrees. This is your frictional force. Okay, because the surface is rough. Okay, yes, I think you can understand and you get it, and you master now your free body diagrams. These are just 3 marks, guys. Okay, yes. So let's move to 2.3. Okay, let me draw a free body diagram for also box Y. So this is for box Y. Okay, yes. So for box Y, you have your tension that is moving it forward, tension force, and you have your friction, because they mentioned that the box Y is a friction of 3 newtons. Okay, yes. So sorry, this was supposed to be shorter. Okay, yes. This vector is supposed to be shorter because the motion is this way, meaning that this one must have a longer magnitude or a bigger magnitude. Okay, yes, but no problem. So there's a normal force because it's on the ground or it's on the surface. You also have your gravitational force acting it downwards. Okay, so that's how it goes for Y, something like that. So you have your frictional force, okay, because the surface is rough. You have your tension force because 5 kg block is pulling 2 kg block using that string. You have your gravity because on the ground there's a gravity acting on it downwards. Fn, it's on the ground. Okay, no, it's on the surface. It's acting perpendicular to from the ground. Okay, yes. So that's how it goes for your 2 kg block. Okay, now let's answer our 2.3, our calculations, our main focus. Okay, yeah, it's calculations. So guys, be able to state Newton's laws. Okay, yes, I made a video, a special video. I made it previously. You can look for it in the channel, stating Newton's laws and so on. Okay, yes, it was a video that was specifically about Newton's laws. Okay, yes. Let's move to 2.3. Okay. Let me check if you can see, guys. So sorry, just give me seconds. I think you can see, right? Okay, yes, you can see. I just wanted to make it sure that you can see. Okay, so 2.3, calculate the magnitude of force F. Okay, so now we have to calculate the magnitude of force F. Okay, the magnitude of this force. Okay, there's a problem right now. Okay, the very first thing is to find what, mind you, is to find our x and y components. Okay, not box x and y components. No, our x and y components. Okay, acting on this block X, which is 5 kg. Our components, our vertical or our horizontal components that are acting at box X, which is 5 kg. Okay, so you know, okay, we wrote and we draw our free-body diagram. Let's redraw it. So you know that here we have this, we have normal force, we have a gravitational force, we have this force, the applied force, our force, okay, given there, and we have now our Fx, okay, our Fx is our X component, okay, and we have our Y component moving upwards, okay, which is our Fy, okay. So this makes us, or this creates a triangle, and this is 30 degrees, okay, and we have a frictional force and a tension force, Ft and frictional force, okay. Yes, so you know that our Fy is the opposite side, and this side that is made by F or created by F is our force F, or force applied there, is our hypotenuse, this side, and this side is our adjacent side, which is made or created by Fx, okay. Yes, so our angle is between which is between the adjacent side and the opposite side, meaning that we have your SOHCAHTOA, okay, meaning that this is between adjacent over hypotenuse, your angle, okay. This angle is between the adjacent side, this is the adjacent side, okay, this is the hypotenuse side, this is the opposite side this way, okay, which is made by Fy. So because it's opposite to the theta, okay, that's how it goes. So opposite of our angle is between adjacent over hypotenuse, okay. So adjacent over hypotenuse is equals to cos, okay, cos, this is sine, this is tan, cos 30 degrees, okay. Okay, so adjacent is Fx over hypotenuse side is F, okay, is equals to cos 30 degrees. Let's cross multiply right now, okay. This gives us Fx is equals to F multiplied by cos 30 degrees. Let's get F cos 30 degrees, okay. That's how it goes. So, and this is our X component in this scenario, okay. Yes, moving, okay. Now we have to find our Fy, okay, which is our vertical component in this scenario. You know it's sine, okay. Yes, what's sine? So opposite over, sine is opposite over hypotenuse, looking at this angle, opposite over hypotenuse, okay. So opposite over hypotenuse is equals to sine 30 degrees. Opposite, that's our opposite side there, it's Fy, okay. You can see opposite side, it's Fy, okay. Yes, over hypotenuse, it's our F, the force that is applied, okay. Yes, force that is applied is equals to sine 30 degrees over 1. That's how it goes. So let's cross multiply. Fy multiplied by 1, that gives us Fy, yes. F multiplied by sine 30 degrees, that gives us F sine 30 degrees. That's our Y component. We found our Y component. I think you're still with me, guys, okay? Yes. I won't rush, and I guess I'm not rushing, guys, okay? Yes. But if you have any kind of a question and you think these kind of questions that we're dealing with here are more complex to you or complicated, don't hesitate to email me at bukokwatela, gmail.com. By the way, I'll mention my email on the description below. Okay, yes. Okay, so that's how it goes. Looking back to okay, so they said you must calculate the magnitude of force F. Okay, so in order for us to calculate the magnitude of force F, very first thing you should regard is that you have to assume or to know that, to be able to know that this, okay, you have to regard this important stuff here. These two blocks are moving horizontally, meaning that you are going to say your F net is equals to MA. Let's regard only to the horizontal forces, okay, acting on those objects. Okay, so meaning that we're going to say for block X. Okay, let's first calculate for block. So for block X, F net is equals to MA. Okay, what are horizontal forces acting there on block X? We have your Fx. We have the Fx moving horizontally. Okay, horizontal forces. This is not a horizontal. It might be a horizontal force or something. This is a big problem. Okay, yes, you should know that you should know that a force. Okay, so sorry for going back, guys. You should know that a force, okay, I repeat, you should know that a force that resulted in 30 degrees, okay, or a force that is acting at an angle is a problem, and we must solve that problem so that we can continue easily with our calculations. How to continue easily to our calculations? By solving that problem. We have to first find what the x and y components. That's how it goes. So f of x, and you found your x and y components. Okay, yes. So fx, okay, plus, this is the net force. Okay, all forces acting on an object we have to add. Okay, yes, plus minus the frictional force, this frictional force that was given here. Okay, yes, because we're looking at box X, which was equals to 5 newtons. Okay, this is minus. Okay, again I can say minus. Okay, minus what? Minus the tension force. Okay, the tension acting there in that block is equal to MA. What's our MA? Is equal to 5A. Okay, yes. Oh yes, our acceleration, mind, is equal to 0 because it's on a constant speed. Okay, on a constant velocity. Okay, so Fx, what's Fx? So Fx is equal to F cos 30 degrees. So F cos 30 degrees. Okay, Fx equals to, okay, that's how it goes. Minus, what's our friction? Our friction is 5 newtons. Minus 5, we don't have tension. Minus T is equals to 0 because 5 multiplied by acceleration is equals to 0, or 5 multiplied by 0 is equals to 0. Yes. Okay, think you still with me, guys. F cos 30 degrees minus 5. Okay, so this can be your you can stop here and say this is your very first equation, or you can say you can continue. F cos 30 degrees minus 5 is equal to T. You take T to that side and say this is my very first equation. It's either you can say this is my very first equation or this is my first equation. Okay, yes, it's up to you, guys. Okay, so we're continuing right now. So we have to find for block Y, right? Yes. So for block Y, you know that what force is acting on that block. You know that we have your tension force minus a frictional force, Okay, yes, you know that F net is equal to MA, so sorry for not writing that, guys. F net is equal to MA, all forces acting on that object, it's at Y, okay, minus F is equal to, what's your mass multiplied by A? The mass there is 2 multiplied by 0, that equals to 0. So that's equals to 0. So in this side, what's your tension? You don't know. Tension minus what? Minus F. Your frictional force there is 3. It's equals to 3 newtons. So therefore, your tension force is equals to 3 newtons. Okay? Yes. Tension force is equals to 3 newtons. Okay. So it's very, very easy right now. Okay. Let's continue. Continue. Okay, I'm just going to write here, guys. Also, I'm out of space. Okay, so tension is equal to 3. It's easy right now. We have to substitute there in that equation. Okay, this becomes equation 2. Substitute equation 1 and equation 2. So substitute there. Okay, because your tension is equal to 3. So this becomes F cos 30 degrees minus 5 is equals to, what's your T? Is equal to 3. Then you can say F cos 30 degrees is equals to, take that 5 that side, comes to 8. Okay, it becomes positive. 3 plus 5 is equals to 8. Okay, think you're still with me, guys. Okay, cos 30 degrees over cos 30 degrees, and therefore our F is equals to, because this cancels this, we're left with F, and in this side we have to say 8 divided by cos 30 degrees. Let's press in our calculators. 8 divided by cos 30 degrees, cos 30 degrees, that gives us 9,24 newtons. Okay, yes, rounded off, 9,24 newtons. That's how it goes, guys. Okay, that's how it goes. So this is our answer, and this is how we have to work. Okay, yes. Okay, so important concept that I'm going to go back to is the constant speed. Okay, mind you, if they said constant speed, meaning that your acceleration is equal to 0 and working with Newton's laws. Secondly, okay, but I was supposed to start with this one, guys, which is very, very important. This is highly vital for you to always apply and for you to always consider. If ever you're given again a force that is acting at an angle, as you can see here, which is that is rotated in 30 degrees. Okay, our force is rotated in 30 degrees. So this basically means that, okay, so we can't work effectively, or we can't work to the, meaning that we are going to the right direction if ever we're going to use this force. Yes, so we have to find the force that is related to this, that is acting upwards and that is acting horizontal, which are called vertical, okay, and the horizontal component. Okay, yes. So if ever your system is moving horizontal, you're going to use horizontal component, which is Fx. And if ever you are regarding forces that are acting vertical, such as your normal force and your gravitational force and other forces that are acting vertically, you can also use your vertical component, which is Fy. So in order for you to work effectively, you have to first calculate the y component and suddenly calculate the x component. So that's how it goes, guys. Please don't forget to subscribe and share this to your friends, okay? And please tell your friends to subscribe to the channel and watch these lesson contents. More content is coming, guys. Thank you so much to those who have subscribed. I appreciate. See you next time. Cheers.